Now, one of the things that you talk about, and I think your experience kind of justifies your perspective on this, is that you've been talking about new school versus old school signal integrity. What do you mean by that?
Oh, yeah, thanks. I think that's a really relevant question and a good place to start in this. I mean, you just heard me say in the late 80s, nobody believed that PCB traces were transmission lines, okay? They thought everything was just a capacitive load and you just simply waited for it to charge, and that there's a picture in my book that shows, even for back then, that was just not true. Okay, so that's almost the definition of old school. There were a bunch of things that went along with that, like terminations and topologies and ground return and these are really good and important concepts. But as I work with customers now, no one is debating those things. No one is like, I haven't been asked in 20 years to remove ground planes. Like, everyone's convinced that we need ground planes. We need shields. All right. So there's a question.
Well, you would
go ahead.
You would be surprised what some students come up with sometimes as far as grounding, because apparently there's a new generation that I guess needs to be convinced of that again.
Yes. And but this is the baseline. Okay. So maybe I should say it this way, in the higher speeds, nobody's asking about that. I guess as people enter, they have to have that baseline. They have to have what I'm referring to as old school. Okay. But as I work with customers and as I go out and teach these things, maybe it's somewhat to my advantage, but I think it's to everyone's advantage that we take a lot of this as givens, because there's a lot of good material out there that will show you that, persuade you of that, teach you that, right? So that way we get to talk about what's happening right now. Okay, what are we? I mean, there was a time that we overlooked transmission lines. There was a time we overlooked ground planes, right? But what are we overlooking right now? Okay, so with my book here, I think one of the most interesting things is what I don't talk about. so it's more like what I'm saying is it's the new school in the sense of I mean, I have a great slide that shows this, and we won't get into it now, but that's the premise. The premise is what things are at least the leading edge, tier one, whatever you want to call them. What are they persuaded of now? Okay. And what can we leave behind, and what new discussions can we get into? Because like I said, every speed jump has leveraged a different piece of technology. So I have to talk about new things. I have to talk about different things. What's relevant now? So that's all it really means.
Sure, I understand. I mean, as the enabling technology continues to shift, it's going to always be a new thing. I think the most recent one that has started enabling the faster and faster speeds is equalization. And so then you have the different types of equalization. And so it's always a new type of thing. And it seems like every so often some PhD student comes around and figures out a new way to do it and get us over that next hump.
Yeah, it's a fascinating, migration, and you're right. The ball keeps bouncing, it keeps changing, and I mean, what a great field to be in, though, right? What an interesting industry. Like it's always reinventing itself. It's always changing.